Good morning, everyone, and thanks for joining us here today. One of the themes this week at the conference is about helping customers do enterprise migration and bringing those workloads to GCP. As you probably heard Thomas talk about in the keynote yesterday, we've really been investing in lots of solutions to bring a whole variety of enterprise applications and workloads to Google Cloud. In this session, we're going to take a deeper dive in one of those particular areas, namely Windows. And hopefully, you're all running Windows, and that's why you're here. Just a quick housekeeping reminder, we really appreciate feedback, so at the end of the session, please enter in the app so we can actually make sure we're making improvements over time. So joining me later on stage will be Souvik and Simon. I'm going to start with an overview of Windows, what we're doing on GCP, and why customers want to come to GCP for their Windows applications. And then Souvik will walk you through the journey of bringing those workloads actually onto GCP, talk about some of the new capabilities and features in a little more detail, and Simon will have a number of demos to show you what we've been building. Now, when you think about enterprise workloads, I think most people recognize that there's a pretty large footprint of Windows running in your traditional enterprises. And we've made it a priority for us here at GCP to ensure that Windows and the entire ecosystem is treated as a first-class citizen across our products and our platform. This started several years ago, where we started just adding capabilities like basic Windows Server images in Compute Engine. But we've been investing in many other capabilities over the years aimed at operators and infrastructure admins, as well as developers, to, again, ensure that we have a whole set of capabilities for anybody who really wants to run Windows on the platform. So whether it's just running the operating system itself, or now more recently starting to have managed services like AD or SQL Server, and just really rounding out the support that's available on GCP. So with this investment, we've now gotten to the point where we have many thousands of customers successfully running Windows, and really wanted to say thank you. Hopefully, many of you are already customers running Windows on GCP, but if not, hopefully you will be soon. So why are some people doing this? Travix is an online travel company, and they've actually had a pretty standard public cloud use case. They had spikes in their traffic, and so they wanted to be able to burst their Windows workloads onto GCP. They've been very successful here. And again, this is the kind of use case that you might recognize as a pretty standard public cloud use case. Volusion is another customer. And for them, they're in the e-commerce software business. And what they found is that they want to be able to take advantage of the broad infrastructure investment that Google's been making. It's difficult for a lot of companies to actually continue to invest in the infrastructure. And they wanted to focus on their core competence, on the software for their e-commerce platform. And so relying on the infrastructure we're providing allows us to each specialize where we really have the expertise and core competence. But these aren't the only reasons. So let's actually just take a couple minutes and look at some additional reasons why customers really want to come to GCP for their Windows applications. Now, many people, it starts with just lift and shift. This is probably the bare bones, the basic approach. You have some workloads you actually want to just run on the platform. And as we've been talking about through this conference, we're investing in making sure we have the infrastructure as a service platform that's best in class for any of your lift and shift workloads. But it's much more than just lift and shift. We look at everyone being on a modernization journey. And when you're looking at that path to the future that you're envisioning as you transform your businesses, some applications you will lift and shift, others you will choose to modernize. And what you'll see in some of the demos later today that Simon's going to give is that you can actually modernize some applications, including Windows, without making any code changes. And so our approach here is to meet customers where they are, allowing you to decide on a per application basis, which ones do you want to lift and shift, which ones do you want to modernize, which ones do you want to move to PaaS. And it applies whether you're running Linux or Windows, independent of the operating system. So beyond, and so as you're looking on this modernization journey, an important belief that we have is that we want to have open ecosystems, open software platforms, so that there's no vendor lock-in. So while you may still be running Windows, you can come to GCP, start thinking about how do you integrate with some of the open platforms like Anthos, like and Kubernetes. This is all built to run on top of Google's infrastructure. We prioritize reliability and efficiency, put in a lot of investments in scalability, and we innovate a lot. This underlying infrastructure is the same to a large extent that powers 8 products that Google has that each has over 1 billion users. So search, YouTube, ads. That is the same underlying infrastructure that we've made many, many years of investment. And that's available for your Windows workloads as well. Now, part of that infrastructure investment is around innovation. And as you heard in today's keynote, when Sudhir and Andrew talked about some of the investments we're making around BigQuery and data analytics or around cloud AI, bringing your Windows workloads to GCP then allows you to plug into these other investments that we're making. And so we're seeing a lot of customers want to be able to come to GCP because they want to tap into those opportunities. And it provides a full ecosystem for that support. So hopefully this just gives you a really quick overview of some of the things that people are considering when deciding to move Windows to GCP. But at this point, I want to introduce Souvik and Simon, and they're going to come up and get a little bit more into the meat of what's happening on Windows, and particularly the journey to Windows modernization.
Thank you, Jack. Hello, everyone. My name is Souvik, and I am part of the Google Compute Engine product management team. And as Jack said earlier, I'm going to walk you guys through some of the recent product improvements that we have been making on our Windows platform. And in context of the typical customer journeys that we have seen, a lot of our enterprise customers started executing for Windows on the GCP platform. And in general, the journey goes something like this. They start by trying to get an understanding of what they have on-prem and what is the best way of migrating them to GCP in the most non-disruptive way. I'm going to talk about that. Once they have migrated, the questions are usually around how do we operate these workloads in GCP efficiently? And we are going to talk about what capabilities we provide today and a number of really new exciting capabilities that are going to get launched this year and in the early parts of next year. And lastly, when customers have started running their operating workloads on GCP, the next question then becomes, how do I modernize? How do I move to a more Kubernetes, serverless world where I can take advantage of the AI, ML, and additional capabilities? And we are going to talk about, and Simon is going to demonstrate a few ways of making that happen rather easily on GCP. And as I get started, I wanted to introduce this application called the .NET Pet Shop application. It's like a very typical Windows application we see in many, many data centers, written quite some time back, not very well, and it is one of the few things kind of holding you back, and some of the applications that are more difficult to modernize. And what Simon is going to do today is to walk you through how you can modernize this particular application using the capabilities that we have launched onto GCP during the demo, okay? So, but first, how do we get started? So the first few questions we get from our customers is, how do I start? Like, next question we get once we answer that is that, how much is it going to cost us? Everybody is aware of complexities and the costs associated with Microsoft licensing, and how do we think about that and how do we manage that as we move to GCP? And then, once they have answered those questions, the questions become, it's a very tactical kind of questions regarding how do we actually migrate those applications without disrupting the business users onto GCP, and we're going to talk about all of them now. But before I get into the details, I just wanted to point out this website called the Migration Center. The link is cloud.google.com/migrate, which is the central place for the repository of a lot of the information that we are going to refer to today and much more. So please reach out, hit this link to get additional information if you need. So the first question that customers ask is, what do we have in our environment? Right? What are the applications? How do they talk to each other? What is their physical footprint? what should be the right physical footprint on GCP. If I move this application, what other applications will break as we, as we, as we migrate to GCP? And that's a very non-trivial question, because a lot of our customers have accumulated a portfolio of applications and infrastructure over many decades. And just going in and understanding what they have can be non-trivial. And to that purpose, what we have done is we have partnered very closely with a number of discovery assessment and planning tool providers like Cloud Physics, StrataZone, Risk-Remote, Cloudemize, and you can see most of them in the show floor today. And you can use these technologies with the IP being provided to you by Google for free to perform this assessment for you and to come back with crisp recommendations on how you should be moving forward. For example, typically the way these products work is that install them inside your VMware environment or in as an appliance inside your data center, and it will come out with very specific types of information like how different applications depend on each other, right? It also comes out with recommendations and estimates on how much cost savings you will benefit from as you move to Google Cloud, and what type of configurations, machine shapes and sizes, et cetera, and physical infrastructure you should be using on GCP. So again, very helpful to get started, and all of these vendors, or most of these vendors, are in the show floor today. Find them and talk to them and get started in this journey. No conversation about Microsoft usually is complete without a discussion regarding their licensing. And we are going to talk about one of the biggest concerns that customers have today regarding migrating enterprise workloads from on-prem to GCP is the licensing cost. Before getting into the details, I just wanted to highlight a couple of key tenets of the standard Microsoft Enterprise Licensing Agreement that many of you have. And again, there is a caveat that we are not Microsoft. We cannot authoritatively talk about the explicit contract that you have with Microsoft. That you'll have to talk to your procurement and financial folks. But we can talk about the general tenets of the standard Microsoft Enterprise Licensing based on what we see publicly available. And that has two primary tenets. The tenet number one is that if you have bought an enterprise license from Microsoft at some point of time in the past, let's say decade plus, there is a clause that compels you to make sure that the license you bought should be run on a piece of hardware that is fully dedicated to you. And it also has a tenet that once you have applied that license to a piece of hardware, that license cannot be moved from that particular hardware for no less than 90 days, unless there is an exceptional event like the hardware failure, et cetera, et cetera. And the challenge with these two clauses is that if you look at any public cloud, including Azure, it functions on a very large pool of physical hardware with VMs kind of running around or running on top of it, and that provides the scalability and the benefits and efficiencies of the public cloud. And that ends up violating these clauses. So what happens is that Microsoft sells in a special type of license called SPLA licenses for running Windows workloads on GCP and other public clouds. And SPLA license is great to get started. It's also very efficient for certain types of spiky workloads, but the challenge is it's costly, especially if you have already a drawer full of Windows licenses you're using from on-prem environments, and your finance team or the procurement team doesn't want to rebuy those licenses again for running on cloud. And in a typical scenario, we have seen that the cost of running a Windows VM in a public cloud, half of that cost can potentially be licensing costs, right? So we have been working very hard to figure out what is the best way to enable our customers to benefit from cost efficiency of the cloud without having to incur this extra cost. And from this year, we have a special type of node, which is called the sole tenant BYOL nodes. This node is specially architected in a way so that it remains dedicated to you or our enterprise customers without any other customers' code touching these physical servers, and these physical servers, not the licenses associated with these physical servers, not moving around from server to server. So what it does is that it allows you to meet the criteria of enterprise licensing agreement, the general enterprise Microsoft licensing agreement, and start bringing in Windows and Microsoft SQL and other licenses to GCP and not having to buy these licenses. And it has proved to be a huge enabler for many, many of our enterprise customers in migrating traditional Windows workloads onto GCP. In context of licensing costs, there's a couple of other things that I will highlight. There is a number of platform features in GCP which actually makes it much more efficient to run Microsoft workloads from a license cost perspective on our platform than others. One example is custom VM shapes and sizes. Like as you know, many Microsoft applications have based on the number of core licenses. And if you have large, chunky gaps in the types of VM shapes and sizes you can create, what happens is that you may have to over-provision the size of a VM on the number of cores. And because of that, you may end up actually paying significantly more on licensing, especially for the really costly applications like Microsoft SQL Enterprise Server. GCP, on the other hand, allows you to have custom VM shapes where you can actually tightly fit the shape of a VM to the type of workload you are running, helping you save many, many thousands of dollars on licensing costs. We also have things like per second billing, which basically means that you pay for these licenses on Microsoft SQL, Windows, etc., for exactly the type of usage that you are doing, not any more, not any less. So for example, if you have a very spiky workload that goes up and down at various times of the day, rather than having to buy licenses at the highest watermark, running on GCP, you can actually get the license savings because it's just going to charge you for the seconds that are using, not the highest licensing levels. And there are many other capabilities like preemptible VMs, sole tenant overcommit that helps in the licensing cost savings. And just to show you the magnitude of the cost saving that can be achieved by running these workloads on GCP, this is an anonymized analysis we did based on work we are doing with a really large European enterprise customer. So, and as you can see, when we just picked up the standard VM shapes and sizes without applying any of these optimizations on the licensing cost side that we talked about, their monthly cost was something like 1.4 million euros. And once we applied BYOL, CPU overcommit, et cetera, the price came down to almost half of that. So the magnitude of the savings can be massive, right? But we also understand that it is really, really complicated to figure out what is the optimal way of migrating Windows workloads or Microsoft workloads in a license-optimized manner. And that is why we have been working with a number of our partners, like the discovery assessment and planning tool vendors, so that they can actually provide you automated recommendations on exactly what is the way for migrating these workloads that provides you most efficiency and most cost savings, right? So again, I would strongly recommend you to talk to our partners and deploy their tools to get a crisp understanding of what is the art of possible and how much cost savings you can incur on running Microsoft workloads on GCP. So now that we have talked about how to get started, the next question that usually comes up is how do we migrate applications in a least disruptive way? And again, my colleague Simon is going to show you a demo, and the context of the demo is this old .NET Pet Shop application. And by the way, by the time we complete the migration and the modernization, we will have this application running in GKE using Cloud SQL and Managed AD, scaling up and down and doing all sorts of funny acrobatics. That's of course not possible for the app to do in on-prem right now. Okay? So up to you, Simon.
Thanks, Souvik. So we are going to talk about migrating the Pet Shop .NET application to GKE, but it all comes in stages. First of all, we need to make sure that our application basically runs on Google Cloud Platform. Let's assume that the use case is quite typical. It runs on premises, and we want to migrate it into Google Cloud Platform, first to run on the VMs. So basically, the goal is to get from the stage where we have the application up and running on a VM, on premises. In our case, we took the original pet shop application developed over like 15 years ago. It all runs on a VM, both the SQL Server and IaaS. Obviously, scaling application like that is really hard. And we want to bring it to the point where it runs on Kubernetes engine, and we can scale it much easier. The database is going to be managed SQL Server, and so scaling that is basically Google's problem now, because it's a managed service. And for the front end, we are going to scale it on Kubernetes using the tools that you might be already using for your other deployments, which might run already on Kubernetes. OK, so first, let's talk about how do we migrate the application from on-premises as is to run on Google Cloud Platform on a VM. So the solution for that is Migrate for Compute Engine. With Migrate for Compute Engine, you can do riskless migration from on-premises to the cloud, or also running from other clouds and migrating all the way to Google Cloud Platform. It takes care of everything. It takes care of licensing. It takes care of security, of drivers, certain configurations that are involving networking. So everything is being done by this solution. And you don't need to change the source code of the application that you were running on premises. It basically takes the VM that might be running, let's say, on VMware, and then moving it to run on GCP. Additionally, you get the benefit of testing. We recognize that sometimes you might run the workload, migrate it into the cloud, and then figure out that something is not working the way that you desire. So you can safely switch it back to run on premises if needed. This solution allows you to do all of that. So let's take a look. OK, so the architecture of the solution is this. In our case, we run the VMware farm on premises. There are multiple VMs. In our case, we are going to talk about the pet shop VM. And we need to migrate this into Google Cloud Platform. So we need to establish a network between Google Cloud Platform and our on-premises deployment. And the component that will help us with this is Velostrata component. So there is a backend side that is installed in your VMware, and there is a server-side component that is installed on Google Cloud Platform. Now, once this is done, what we can do is basically do the actual migration. So let me show you on VMware how we can do it. OK. So what you can see here, this is the actual on-premises deployment that I have. In this case, we have 2 VMs with Windows. Now, the actual migration takes some time. So I already migrated one of the VMs to kind of show you the end result. But basically, it can be as little as 10 minutes to get this from on-premises to run on Google Cloud. And what you need to do once you have this VM and once you have the component of Velostrata installed, you get this additional menu called Velostrata Operations. Velostrata is the former name of Migrate for Compute Engine. And then here you have multiple options. You can run the VM in the cloud so that the storage is still going to be on premises, maybe for testing purposes and some other reasons that you might have. Or you can do the actual migration, or you can test the migration and then move back. This solution also knows how to deal with dependencies. So if you might have multiple VMs, so your cluster is composed from multiple VMs that might run your application, you can define the topology of your deployment, and then Velostrata will move it in the right order so that all the dependencies are preserved. So in this case, I'm having this pet shop application running on the first VM, and this is running on premises. And just to save on some time, I already migrated the second one. This is just a copy of the first one. So this copy is already running in the cloud. And then if we want some sort of proof of that, OK, just this is the VM that we actually migrated, and you can see that it's actually deployed into a Google Cloud Platform. All right, so let's get back to slides.
OK, thanks, Simon. So now we're going to talk a little bit about how do we operate or help our customers operate large Windows environments on GCP. And as we start this discussion, a few questions that come up frequently is how do I start or deploy new applications? How secure is it? How does it perform? How do I manage my applications, so on and so forth? And the great news is that we provide customers a large number of options to execute in all of those above. As you can see, we provide and have been providing for quite a few number of years a large library of Google engineered and Google optimized Windows and SQL images in the GCP Pantheon console. You can actually just go in there and spin up these images and start using them immediately. They have licenses built in if that's what you want to use. And they also are supported by Google. As in, let's say, if you have a challenge with any of these images, you don't have to call Microsoft. Google will be the single point of contact for providing any support. And we have very high quality agreements with Microsoft on how to debug and work through issues in the unforeseen eventualities that you may encounter a problem. So you will not be going to have to work between Google and Microsoft to get resolution to your issues. In case you do not get the types of images that you are looking for, we also provide an extensive marketplace for you to spin up additional applications that are on the Windows platform. And the great thing about the marketplace solutions is that the overall monthly billing for these solutions are all integrated with the GCP billing. So you are not going to have to do contracting and pricing and billing with each of these vendors individually. It's all packaged together tightly as part of the single platform. As no discussion about Windows is complete without this upcoming end of life of Windows Server 2008. And at Google, we have done a number of things to make it easier for our customers to navigate this event. For example, if you have Windows 2008 images running on GCP, we actually provide multiple options of doing in-place upgrades. So you can say, hey, I want to upgrade this image from Windows 2008 to something else. You click a few buttons, it's done. And in case you don't want to upgrade, you can keep running at your own risk on GCP. We wouldn't stop you. It's just that we will recommend you to upgrade at your own pace when you're ready. We have a number of security features like shielded VMs, which protects you from malicious rootkit and bootkit type of attacks, if that is what you need, in addition to the variety of additional security capabilities that are part of the overall GCP platform. One of the key differentiators of GCP is live migration, which basically means that VMs can move from pools of physical hardware across because of maintenance and other reasons without any disruption to the usage so that the servers are not rebooted. And that's a bigger advantage in many situations for Windows workloads because Windows servers take more time and are more susceptible to having challenging situations if they are rebooted. And that reason is kind of taken away with our live migration technology. Additional capabilities that we have announced this year and are going to be available to you sometime early next year are things like patch and config management. This provides a single console for you to look at all your VMs, Windows, as well as Linux and others, which tells you what is the state of those VMs compared to patching and configuration. Are the configurations of those VMs drifted from maybe a standard configuration you have set for your VMs using Puppet, Chef, or some of these config management tools like that, and really automates and simplifies the way of managing large pool of VMs on GCP. We are also very happy to announce the availability of managed SQL services on GCP, and my colleague Simon is going to talk about that and show you a quick demo of how to get that started.
Thank you, Souvik. So with Managed SQL Server, you get the option to focus on development of your SQL Server database and offset all the management procedures into Google Cloud Platform. There are 3 tenets that we offer. First is compatibility. With compatibility, you get the same tool set that you were using before, such as SQL Server Management Studio, and OSQL, SQL CMD, or others to work with your SQL Server. It all works. You just continue to use the same tools, but the SQL Server that you're using is going to be Managed SQL Server by Google. It is fully managed service, so you don't need to deal with patching, replications, scaling, and other procedures such as backups and restores. We offer high availability, over 3 nines of SLA, and this service complements our other managed SQL services for Postgres and MySQL. So let's see a quick demo of how we can get started with Managed SQL Server. So in order to access the Managed SQL Server page on Google Cloud Platform, I'm going into the SQL pane. And here, I already have a few databases, but let me show you how you can create a new one. So you just go to the Create Instance, and now that we introduced the beta of Managed SQL Server, you have the option to choose SQL Server. So in this case, we are trying to create a new SQL Server instance. You just give it a name. OK, then you need to give it a password. Now, this password is for the user that's going to be administrative user from your side. So Google administers the SQL Server itself, but you need an admin user to be able to manage your databases. So this is where you set the password for that user. And the username, in this case, it's going to be SQL Server. That's the default. Then you choose the region and the zone where it is going to be located. You can expose it using public IP, or you can leave it only with private IP so that only your cloud instances will be able to access it. You can also choose the SQL Server version that you want to work with, as well as its configuration. If you have any particular configurations for your SQL Server instances, you can set these flags over here. And moreover, we said that this is a managed service, and so here you can decide when the maintenance tasks are going to be performed by Google for your SQL Server instance. So in this case, I can check any time that I want, or time window, and proceed. So this operation will take a little bit to create, but we already have a few instances that I pre-created for you. And so let's try to see what I can do with the existing instances. So I'm entering the instance where we are going to deploy all our pet shop databases. And so you can see here, it gives me all the details of how I can connect into that instance using, in this case, the service account for authentication. I can create users from the portal. I can also create new databases, and I can import my existing databases. So in this case, we are going to import existing databases. So let's do import, and this is basically the restore that you all know from the SQL Server. So I can restore from anywhere, but in this case, I already uploaded some of the backups for a pet shop application into my storage bucket on Google Cloud. And so I can just find these backups and restore them. OK, I can give it a name. And hit on import. So what is happening now is that my database is being restored, And then I will be able to access this database using the same toolset that you all know. So let's try to actually access this SQL Server instance and maybe explore one of the databases that I already pre-created using, let's say, SQL Server Management Studio, okay, the tool that you often use for working with databases, with SQL databases. So one important thing that we want to ensure is that the connection that you are making to your managed SQL Server database is secure connection. And so we created this SQL proxy that allows you to make sure that the connection is secure. So I already downloaded this proxy. It is an open source component available on GitHub as well as Google documentation. So in order to connect to my database, all I need to do is type Cloud SQL proxy and then provide the instance to which I want to connect, as well as the credentials from Google Cloud Platform's perspective to be able to authenticate against that database. So in this case, I don't provide credentials explicitly because I already have my service account set up on my machine, and so it will just use the service account. So we start the proxy, and what it will do, it will make sure that the connection is secure, it will use SSL, and it will make my computer think that I'm working against database on the local host. So now it says ready for new connections, and what I can do is just go into a connection pane, hit my password, click connect, and in a short moment, it should get us going against the SQL Server that we created. And here, you can explore and see all the databases already restored, all the patch up databases that we'll need in the future in order to modernize our application. So this is really helpful to get into the state that you can work against your SQL Server, but offset all of the management capabilities to Google Cloud Platform. So let's get back to slides. OK, another service that we are going to announce is Manage Active Directory. We know that many of the companies that use Google Cloud, they use Active Directory for identity management. And so one of the common asks was how to get out of the business of dealing with all the patching and upgrades and security issues on domain controllers and focus only on the management of the identities. So this is along the similar lines of Managed SQL Server, except that in this case, we are going to deal with managing identities using Active Directory. So you can connect your existing domain into this Manage Active Directory domain. You can also create a new Active Directory domain on Google Cloud and then manage identities over there. You can also establish trust relationships and automate all of the Active Directory ongoing operations on domain controller by just using this service. So let's see a quick demo of it. OK. So with Active Directory managed, all you need to do is go to security, and one of the options you get there is Manage Microsoft AD. When we get here, we have two options. We can either manage existing domain, or we can create a new Active Directory domain. So let's see how the creation works. In creation, I just provide the fully qualified domain name. I provide the network range on which this is going to be available. I can create it in particular region. And I also use the user called setup admin. This is the most privileged user that you get from Google Cloud on the new established domain. And then you can use that user to do all the operations and maybe some delegation to additional users that you will use to manage your domain. Once the domain is created, and this operation is really taking some time, it will be about 40 minutes to create a new domain. But once that is created, you can basically manage the domain using the same set of tools, such as, for example, Active Directory users and computers. Okay, so this is this domain that I created. And all of the machines that you add into this domain will be added under cloud computers. And then you can create users and basically do whatever you typically doing against the Active Directory domain. All right, thanks. Let's get back to slides.
OK, thanks, Simon. Let's quickly talk about modernization. So once you've got your applications up and running on GCP, you will find that GCP provides a large number of tools for modernizing your applications, starting from Kubernetes, managed Kubernetes options for converting your Windows VMs into GCP. We also provide extensive set of .NET client libraries that basically wrap all GCP APIs that are available for building any applications on our platform. If you are a Microsoft .NET developer and you are more familiar with Visual Studio and want to continue to use that, we provide a large number of plugins for the Visual Studio to make it easy for you to build, as well as to debug your applications on Visual Studio and .NET and .NET Core. So I would actually request Simon to show another quick demo of Windows Server containers on GKE. Simon?
Thank you, Souvik. So what we are going to do now is try to do the final stage of our modernization journey and basically take our application to Google Kubernetes Engine. In order to do that, we need to deal with basically two things that were part of the existing application. One is take the SQL Server that was running on premises and make sure that we now work against the SQL Server managed. So our application, and this is a .NET application, it is using connection string to work against SQL Server on premises. We need to change that to work against SQL Server managed. And then the second step, we need to take our existing VM and containerize it so that we can run it on Windows nodes in Kubernetes Engine. So let's see this set of steps that we need to do to get this to work. OK, so basically what we need to do first, we mentioned that our SQL Server by default was a SQL Server on premises, and our application is using the connection strings to connect to SQL Server. So I already changed this so that instead of working on premises, it will work against our managed SQL Server. Now, in the previous demo, I showed you that we will need to use the proxy in order to make sure that our communication with managed SQL Server is secure. But that will also make our front-end thing that it works against the local host. So I already updated the server to be the local host, as well as username and password, which is part of automated process to update the password. And so now we need to build container images to get this going. So we are going to first Dockerize the SQL proxy that we need to run against managed SQL Server. So this is the simple Docker file that we can use for that. We base off of Microsoft's image for Windows. We add this Cloud SQL proxy into that image, and we just run the same command that I showed you in the previous demo of managed SQL Server. Next step, I need to containerize my application. Now, my application is a simple IIS application from many, many years ago. And so Dockerizing this application is really simple. I can just base off of Microsoft's image. This application was .NET Framework 2.0, and this is part of Microsoft ASP.NET 3.5 base image. we get into the work directory of IAS, and we copy the content of our application into our Docker container. So these are the Docker files that we need in order to containerize. Now we need to build container images and deploy this into Kubernetes engine. So in order to build the container images, I'll show you the command that we need to run. It's just Docker build. If you want to build container images on Google Cloud Platform, we provide VM images that already come with Docker, so you can build your container images on GCE VMs. And the command that you need to run is Docker build. You need to tag it. And similarly, we need to build the SQL proxy command. Then we need to push these images into container registry with Docker push. And the last step, we need to deploy. Now, in order to deploy, we need to use the familiar Kubernetes manifest file. And there is a lot of boilerplate here, but really the important step is that we need to make sure that it runs on Kubernetes on Windows nodes. Okay, this is really important because our two containers that run together on the same pod, they all need to be on the Windows node. So this is the important part. Once this is done, what we can do is just deploy this application into Kubernetes using kubectl apply. And when this is done, we eventually get into application working on Kubernetes engine. And just to kind of make sure that this is the case, we can do, let's say, get pods. Okay, and it is showing me that there are two instances of this PetShop application up and running. And if we want to scale that, it is as simple as saying something like kubectl scale deployment IAS with sidecar replicas equals, let's say, 5. And then basically when I hit that, it will scale my application. So just to recap, let's get back to slides. Even applications which are really, really old and you don't want to change their source code, there is still a pathway for them to be modernized and moving to Kubernetes so that you can use the same set of tools to scale the legacy application just like you would do normally with the cloud-native applications.
Thanks, Simon.
Thanks.
So let's quickly wrap. So what we talked today is, you'll see that GCP provides a large number of capabilities for managing Windows applications better in case it cannot be containerized. In case an application can be containerized, as Simon showed you, it is very easy to get them onto GCP, and as well as use services like Managed AD, Managed SQL to make it much more efficient. If the application you have can actually be converted from .NET to .NET Core, you can actually run those applications on .NET Core running on Linux, making that even more open and even more efficient. And finally, if you have an application that can be rewritten, or you want to rewrite that, we provide a very large set of .NET libraries as well as Visual Studio capabilities and codes and integrations to make writing those things easier, taking advantage of App Engine and Cloud Run, right? So it doesn't really matter where your application fits in, where you are. We are a good solution for you to get started in your modernization journey with Windows. And again, to wrap, we have seen our commitment, our strong commitment to building on our application roadmap on Windows. Reliability of Google overall is inherited by any Windows applications you are running on GCP. We already have a large set of capabilities that we are in, and as you can see from just the set of capabilities we have announced in 2019, we keep on investing. And we have thousands of customers already running Windows on GCP. So you won't be alone, right? It's a safe choice and puts you in a path towards modernization to a much more open, non-licensing restricted world. Thank you very much. I don't think we have time for questions now, but we will be waiting right outside to take your questions. Thank you very much.